These are a few solutions for Math 3 Unit 1, Worksheet 1, and I'm going to start with question number 3. So to graph number 3, which is our directions, we need to get y by itself. So to get y by itself, I need to move the 3 to the other side, and so I want to divide by 3 because it's currently multiplying, and the inverse of multiplying is dividing. So 3 divided by 3 is just 1, and I don't need to write the 1 for the y. So I will have y by itself, and I'm going to move it to the other side or flip it around just so that I have it in the right order. And then 2x divided by 3 is the same as 2/3 x. So if I want to graph this, my start point is 0, 0. So I'm going to start at 0, 0 because I'm adding or subtracting nothing to x, nothing to y. When x is 0, y will also be 0. And then my stretch or my slope is the number multiplying x. And so I'm going to use my slope to find my second point. So I'm going to rise 2 and run 3. So from my origin, I'm going to go up 2 because it's positive, and to the right 3 because it's also positive. And that's enough points to graph a line, but to find my additional point, I'm going to make these both negative, so a double negative is the same as a positive. So I'm going to go a double negative, so now I'm going to go down 2 because it's negative 2. I'm just thinking it, not writing it. And left 3 because both of those would have to be negative. And so I know this is linear, so I should be graphing a line. Okay, I'm also going to work out number 6. So I know this is a quadratic or a parabola, so my basic shape will be a U shape that has curved edges, not straight edges. So the squared tells me I'm going to have the U shape. So my start point, so this is in standard form, so I'm going to start at 0, 0, because when x is 0, even if I square it and multiply it by a number, my y value will stay 0. And then my stretch, so not my slope, but my stretch, so I'm going to use a, is the number in front of x squared, so my stretch is 1/2. So I'm going to start with my 0, 0. And so now remember that a stretch is not the same as slope, so I can't go up 1 over 2. But what I can do is I can go up 1/2 and over 1. All right, so I can go up 1/2 and over 1. I cannot go up 1 over 2 because it's a stretch, not a slope. And so now to find my additional point, I'm going to reflect it, so move it to the other side. So I'm still going to go up 1/2, but now I'm going to go to the left 1. And then I can graph. And then if I wanted to, for accuracy, I can actually plug numbers in. So I could plug 2 in for x. So I already used 1. So now if I want to plug in 2, my y value, so I would replace x with 2. And 2 squared is 4. And 1/2 of 4 is 2. So for accuracy, if I wanted to, I could go over 2 up 2 as well. Okay? Okay, for number 8. So my start point for my asymptote is 0, 0. Okay, and that's always going to be for the asymptotes on our parent graph. So that's here. So it's not actually a dot on my graph. Remember, that just gives me my asymptote, which will not show up as part of the actual function itself. It's just a boundary line. So how did I get that? I did not get it by putting 0 in here because 2 to the 0 power is not 0. So I just know that I'm not adding or subtracting anything to x or y. So my start, meaning my asymptote, right, this is the oddball one, is 0, 0. So now my stretch or rate of growth, so also, so we use B, it doesn't really matter what letters we use, all right? So my stretch or my rate of growth is 2. And so from my start point, I'm going to go up 2 over 1. Right? So up 2 over 1. And then I need an additional point. And for my additional point, I always substitute 0 in for x. Okay? So remember, this is for my asymptote, not for my function. So now for my additional point, I'm going to have 0 in for here. Okay, and so I'm going to do y equals 2 to the 0, and anything to the power of 0 is equal to 1. So when x is 0, my y value is 1. So that's going to be right there, right? So another way to think about it, remember, is that your asymptote is on the x-axis. You always are going to go up 1 for one of your points, and then use your rate of growth for the other, so up 2 over 1. Right, that's the easy way to think about it. Asymptote is on the x-axis, up 1 for the first point on your graph, right? Or 1 point on your graph, and then use your stretch, your rate of growth, so up 2 over 1. And then that gives me that graph. Okay, and then one more, number 9. So for question number 9, so this was absolute value graph. So absolute value graph is the V shape. And I probably should have mentioned over here, this was exponential because the variable's in the exponent. So, okay, so absolute value is my V shape. So my start point, which is on the graph for my vertex, is at 0, 0. So because when x is 0, multiplying it by any number is going to keep it 0. So that's actually a point on the graph. And then my slope or stretch or rate of growth is the number multiplying x, so that's -4/3. And so now, because it's linear, meaning straight lines and no curves, I can use it as a slope, like rise over run. So I know that the negative I'm going to put up with the 4. So I'm going to go down 4 and then to the right 3. There's one part of the V shape, and then reflect it for the other. So I'm still going to go down 4, but I'm going to go to the left 3. So one thing that is important to pay attention to when you're doing your homework assignments and graphing is that if it's straight edges, so these two have straight edges, no curves, I can use slope. Up 2 over 3, down 4 over 3. So straight edges, I can use slope. Rise over run. Curved edges, I can't, right? Curved edges, I can't. I need to go up a half over 1. I cannot go up 1 over 2, right? Curved edges, I can only go up a half over 1 because that's how I get my curve. Over here, same thing. I can go up 2 over 1. If it was a half, I can't go up a half over 1. I mean, I can go up a half over 1, but not up 1 over 2. Okay? All right, good luck.